Sari, and today we're going to be talking about color and decision making. So a couple of things we're going to review is your brain, the visual cortex, which is responsible for how we see things. Then we're going to talk about color. Then we'll look at decision making. And then finally, how color helps us make these decisions through response inhibition. So let's get into it. Let's now review our brain. So this is what a healthy brain looks like, and it sits inside our head. And we can think of the brain as being divided into 4 major parts, also known as 4 lobes. So in this picture here, we see it as the frontal lobe in blue, the parietal lobe in pink. Then underneath that, we've got the temporal lobe in green and the occipital lobe in purple. So let's start with the frontal lobe. So the frontal lobe is responsible for making decisions, for planning, organizing our thoughts, and it's also responsible for our personality. Right behind that, we've got the parietal lobe. The parietal lobe is important for processing something known as somatosensory information. So this is information like pain, touch, and temperature. So everything that your senses, essentially what you taste, for example, and what you feel is processed in the parietal lobe. Underneath that, we've got the temporal lobe. The temporal lobe, which is this area in green, is responsible for hearing and memory and emotions. So for example, how you hear speech and understand it, or for your memory, how you recognize objects, or maybe you recognize familiar faces, like the faces of your friends and family, and how you read emotions off of people is all processed in this area. Last but not least, you've got your occipital lobe. That's in the back of the brain, and this area has the big responsibility of processing vision. So everything that you see is processed in the occipital lobe. And this is the lobe that we're going to be focusing on today. So now that we've seen your brain in general, let's focus on that occipital lobe and actually look at an area called the visual cortex. So how is it that some of us can see? So the visual cortex, which we can see in that image there, is a red area in the occipital lobe. So what it does, this area, is that it receives, integrates, and processes visual information relayed from the retinas of the eyes, okay? And then it makes its way all the way to the back here in the visual cortex. All right. So let's see how we receive, integrate, and process visual information that is relayed to the eyes. So we can do that by looking at what is known a visual pathway. So while you're all watching this video and seeing me on your screens, it's all playing in front of your eyes. Okay, and then these images are going to make their way into your pupils, and that's essentially like the middle and black area of your eye. And once those images hit your pupils, they're going to make their way into the back of your eyes on the retina. When the images hit your retina, they make their way into the optic nerve. So that information will make its way into the optic nerve. And then it's going to hit an area called the optic chiasm. And at this area, the information will cross over. So essentially, if I see something with my right eye, which is this one, it's essentially going to make its way into the left area of my brain. So it's going to cross over, make its way onto optic tracts, and then make its way into the visual cortex in the occipital lobe in the back of your brain. Pretty cool, right? So in this case, let's give ourselves an example. If you see some mangoes, right? So the image of the mangoes are going to go through the pupil, which is the black part of your eye, hit your retinas, which is the back of the eye. Then it's going to make its way onto the optic nerve, go all the way to the optic chiasm, cross over, and make its way into the left area of my brain, onto optic tracts, all the way to the visual cortex, where that information is processed. So now let's look at what happens once that information is processed there. That information, we need to know, what we saw and where that object is going or where it's coming from. So those are two pathways known as the what and the where pathway. So let's look at that in more detail. Here, when we get the information about the mangoes and it makes its way into the visual cortex in the back here, in the what pathway, we're going to get information about the color of mangoes, which is red on the outside and yellow on the inside. We're going to get information about the shape, which is round. And we're also going to recognize that this is a mango, a fruit that we've seen before, hopefully. And then the where pathway, that's information about the direction the mango is going in or where it's coming from. So if someone threw the mango at your face, it's important to know how fast it's coming, and if you'll be able to catch it, for example. Or maybe you're just eating the mango. So it's important to know that the mango is actually going to go to your mouth. So these are all information that the what and where pathway, conveys to the frontal lobe. So here we see the what and where pathway. So as I mentioned, here we're going to get information about color. We also get information about like faces, for example. And then the where pathway, that tells us information about the direction things are going in. So now that's essentially a good summary about how vision works, right? How we get to see objects. It makes its information into the occipital lobe, in the visual cortex of the occipital lobe. And then that information is relayed to our frontal lobe by telling us what it is and where it's going. So now how about we talk about color? Which can be pretty exciting. I don't know if you know what color is, but let's see what color is. All right, so color is the stimulation of cells in the eye by light in the visible spectrum. Let's break that down a bit. Essentially what you need to know is that color is light, but it's light that you can see. Okay, so this is the visible light spectrum. It's also known as, light is known as a wave. And so these waves can be short or they can be long. The shortest wave we can see is purple, and the longest wave that we can see is red. And so these are all of the colors that we can actually see, and that's the visible light spectrum. So knowing that, there are something called color deficiencies. And so sometimes not everyone is able to see all of the colors. And one of these color deficiencies is color blindness. It's the inability to see the difference between certain colors, usually the difference between red and green is difficult for some people. Now that we know that, let's see how color might affect decision making. So color blindness can affect simple tasks like selecting ripe fruit or choosing clothing and reading traffic lights. In this picture here, you can see that if you were colorblind for red and green, it could be difficult to tell which fruit is an orange, where the avocado is, which one is the tomato or the apple. And so we can see how color could affect decision-making in this scenario, especially if you have trouble seeing some of the colors or differentiating some colors. And this could be especially dangerous, for example, for traffic lights. So now that we have an idea about what color is and what color blindness can be and how some color deficiencies can affect decision making, let's look at what decision making is in more detail. So decision making is actually a lot of executive functions put together. And what executive functions are, they actually depend on three types of brain functions: your working memory, your mental flexibility, and self-control. So these are skills. You're not born with them, but everyone is born with the potential to develop them. And the more you develop them, then the healthier they are, or the more they can support all your activities. So it is important to make good decisions. So naturally, it's important to develop these skills. So let's look at one of these skills in particular, the self-control skill. Self-control is also known as response inhibition, and it's the suppression of actions that are inappropriate in a given context. So essentially, it's you being able to stop yourself from doing something. Maybe this is clear if your parent has ever told you to think before you act, or maybe your sibling or anyone else in your life told you, hey, maybe you should think before you act. Maybe you should stop, take a moment, and then do what you were going to do. And that is self-control. I think I had a picture there before of puff puffs, also known as buffaloes. So for example, if your goal is to be healthy and strong, then at some point you got to stop yourself from eating too many buffaloes. So that is self-control, knowing when to stop doing something to reach your goal. If your goal is to be healthy, then maybe you're not going to eat 5 buffaloes. Maybe you'll just eat 1. Okay. So now we have an idea about how we can make decisions, and we learned a little bit about self-control. Let's now lastly look at how color can help us with our self-control. So color and response inhibition. So what effect do different colors have on our self-control? And do they actually have an effect on our self-control, on our ability to stop? Well, there is research that suggests that that is the case, that some colors help us stop more than others. And so what researchers did is that they used this really cool task that you can think of it as a game almost, that measures how much self-control you and I have. So this task is called the go, no go task. And what happens is that when you see a green button in this task, you're going to press it. And if you see a red button, you're not supposed to do anything. So you're going to not do anything when you see the red button. Now you can play this game if you're already at home. So if I say green, you can hit the table. Green, hit the table. Red, don't hit the table. Green, 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 red, and that's your go, no go task. So this task helps us to see how much self-control someone has. Now, you could do this task really quickly, right? And see if you're really quick at it. If you're really good at it, you can maybe be super fast compared to other people. But you can also count how many mistakes you make. If you're someone that makes a lot of mistakes on this game, then maybe your self-control needs to be improved upon. But maybe you're actually really good at this and you don't make many mistakes, in which case that means that your self-control might be pretty good. Now, there's always room for improvement for this task. And so don't worry, no matter where you are at this game, you can always improve. And that's the great thing about it. So knowing how this game measures self-control, we wanted to see, is there a difference in the color of these buttons? So if these buttons were maybe yellow and blue or purple and orange, would it make a difference how many mistakes you made? And the researchers found that indeed, red helps you stop better than green. And so what happens is that green is actually the worst at making you stop. So when the button is red, you're able to not make any mistakes or not make as many mistakes, and you stop yourself well every time. But when the button is either yellow, blue, or green, and you're supposed to stop when you see it, well, in that case, you make much more mistakes compared to the red button. So that's how color can help us make decisions. If you want someone to stop or to pay attention, then you might use red as the color because we know that that is a color that helps us stop better. So the last thing I'm going to leave you with is, again, knowing that red helps you stop. And if you want to improve your self-control, then there are a couple of things that you can try to do so. You can actually play this game a couple more times. You can use different colors. You can use colors that'll make it harder. So if you use maybe green or blue or yellow, it's going to make the task harder. And of course, it's going to challenge you. So you might get better at self-control, at response inhibition, and at stopping in general. But there are also other games you can play. So, all in all, what we learned today is that color can help us make better decisions. Essentially, red helps us stop better. And self-control is something that's really important and something that we can all improve on.